So that sort of gets me to the, the weighing. How do I decide, which MCU I should use? Do I use the built-in Sametime SVC MCU, or do I go ahead and look to a third-party provider to be able to say, hey, what's the right balance? Because you have the ability to bring in SVC and AVC clients, that's sort of one of the key areas. That's one of the things that's new in Sametime is being able to mix those SVC and AVC. The problem is the AVC clients are going to get, as I said, the lowest common experience. The clients are, generally, the bigger the client, the worse it's going to look on their screen. I'll get to a couple slides that sort of showcase that difference. Giving these room-based systems, the best experience is important. If you're in how do I put this? If you're sitting down and saying that you need to deploy mobile voice and video today, IBM, when they released Sametime 9, said that as of Q4, they're going to start talking about the mobile strategy. I think that certainly that the IBM team over the next few days will talk about how they're going to video enable Sametime 9 on things like iPads and coming up soon. So if you need to do it today, certainly you can do that. If you need it, several months from now or several weeks from now, there may be some way that you can switch between the two. The other thing that David sort of hinted at earlier is when he was showing the list of the MCU farm, that the whole video infrastructure is designed to be scalable. So the the vManager, the video manager, and the video MCU are designed to scale, but there's some things they can do and some things they can't do. One of the things they can't do is what's called cascade for size. So if you have a very large video environment and you need to bring in lots of video participants, Sametime 9 video MCU is going to sort of max out, and there's no way to sort of bridge from or to cascade from bridge to bridge. Clearly, if you have very large video calls, you should probably be looking at a recording and streaming solution, much like we're on today, but that's a whole other discussion. Obviously, if you have immersive telepresence rooms like Polycom RPX or Cisco CTS, that's another situation where you may want to be on an external MCU. You need to, again, right now Sametime 9 can record audio and content. If you need to do audio content and video, that's not something Sametime 9 can do. Clearly, these are things that I expect IBM to continue to develop and improve on. The key is, where you have these mixed AVC and SVC clients, that's really where you want to start looking for an external bridge. And that gets me to my very favorite drawings. And I'm going to sort of walk you through this drawing. The things to note: who are the happy people and who are the sad people. Okay. There's a host for this meeting, and this is a Sametime client, a Sametime 9 client, and he's able to send his video image to the Sametime 9 server, and anyone who chooses can view him if they're an SVC person. The speaker over here, number 2, he's on a mobile device, but his device is not a Sametime device. It's an AVC endpoint. Could be an older endpoint, could anything that doesn't support SVC, and there are a couple of room systems out here. So when the speaker starts speaking, because he's an AVC-only endpoint, he's going to send his image, and the SVC client, the guy who's going to be happy, he's going to be able to see their individual streams from the other 3 participants. Everybody else, because they're AVC only, they're only going to get what they call voice switched. So the active speaker is going to be visible, not this continuous presence layout. So if continuous presence layout is important to you, then you have to be very, very aware of what happens using the native Sametime 9 environment. So where is continuous presence really important? If you're doing things like training, or you have meetings where you are trying to get buy-in, being able to see only the the last active speaker leads to some disappointment because you don't know what everybody else is thinking. You don't know who looks confused or who doesn't look confused. So the whole point of this is that understand that the limitation on Sametime 9, it's not bad, it's not poorly featured, but SVC inherently doesn't necessarily transcode, or the SVC router doesn't necessarily transcode. All it does is forward packets from place to place, and because of that, it's not able to build this continuous presence window. So if you put instead of the Sametime 9 engine in, you put in an external MCU that's able to actually transcode between those voice and video streams that are SVC and AVC. What you get is you get happier people. That's the short answer. Instead of the endpoints deciding, like they do in SVC, what they're going to see, this MCU, this external MCU, is able to build these custom layouts and send them to each endpoint. So where you have Sametime clients, they're always going to be happy. The problem with the built-in Sametime environment is that the AVC endpoints have no way to get A, high-quality streams, and B, they have no way to get these multi-person layouts. And again, wherever you need to get buy-in from people in meetings, in training classes, in an auditorium, having the ability to see people and see everyone who's up on screen really sort of leads you to the need for that external MCU. So what do I mean by building layouts? I've been showing 3-person layouts. This is an example of a Polycom RMX MCU. What it's doing, even down to the bottom, is building the ability to see up to 16 people and see them all in continuous presence and build those layouts so everybody gets that best possible experience. An external MCU generally will go ahead and let the AVC endpoints even connect at a higher speed because they're able to do this transcoding, this conversion between SVC and AVC.